We have seen the flexibility that knowledge graphs provide to represent information about the world. But how do we go about using them to obtain insights? In this video lesson, we will obtain a high-level overview of how artificial intelligence can help us obtain better answers from knowledge graphs. A common application of knowledge graphs is in the biomedical domain. Let's take a look at an example. We have here a knowledge graph where the nodes are diseases, proteins, and medicines. In this graph, diseases are associated with proteins, and proteins are targeted by medicines. For illustration purposes, this graph is small, but in real-life applications, there can be hundreds or thousands or even millions of nodes. We can answer questions with knowledge graphs by formulating queries. Queries define the conditions that an entity in the graph must meet in order to be considered an answer. In general, queries can vary in complexity according to the conditions that they define. An example of a simple query would ask for entities of a certain type. In this case, we're looking for all proteins in the graph. Therefore, the entities that answer the query are proteins P1 and P2. A second example of a simple query requires following a path of length 1 on the graph, starting from an entity. In this example, we're looking for all proteins associated with disease D1. This requires us to start at the node corresponding to D1 in the graph and retrieving all the proteins to which it is linked. The answers to the query are then proteins P1 and P2. We can also put more arbitrary constraints in the query involving multiple entities. This leads us to complex queries. This query is looking for all proteins targeted by medicine M2 and associated with diseases D1 and D2. By observing the graph, we can see that protein P1 meets these conditions, and so it is an answer to the query. In general, any useful system for query answering should be able to cope with queries ranging from simple to complex, so that the knowledge in the graph can be employed effectively. It is easy for a computer program to take a query and search for the entities that match the conditions in it. However, the results might not be complete if there is information missing in the graph. In the majority of cases, knowledge graphs are built by people within a particular knowledge domain. As science progresses, the graphs have to be updated to reflect all changes. Going back to our example, imagine that scientists discover a new relation between diseases D1 and D2 with a new protein called P3, and this information is added to the graph. What happens if we try to answer the same complex query in our last example? Since there is not yet a relation between the new protein, P3, and any medicine, the correct answer is still P1, because it is the only entity that meets the conditions of the query. However, it seems that the new protein, P3, could be a potential answer, as the only condition it misses is being targeted by medicine M1. Having access to these potential answers would be very helpful to a scientist working in this domain. A solution to this problem can be found with the help of AI. Using machine learning, we can train a system that takes as input a query and outputs a numeric score for all possible entities. The machine learning model is trained to assign high scores to correct answers and low scores to incorrect ones. By assigning a score to all possible entities, we obtain a larger list of candidates than if we had used a traditional system. To train such a system, we must collect a dataset of query and answer pairs. This can be obtained automatically from the graph. Each pair consists of a query and two entities that are correct answers and incorrect, respectively. When training on a large data set of diverse queries, including simple and complex, the model will discover correlations and patterns expressed by the graph structure. This will allow it to produce potential answers to queries even when information is missing in the graph. To summarize, the application of AI to query answering can bring many benefits in domains where data can be represented as a graph. This includes the scientific domain, where machine learning can be used to answer queries and predict links between chemicals and diseases and other tasks of scientific discovery. It can also be applied to social networks and media services where users and products can be laid out in a graph for building better recommender systems.